Water-cooled chiller. Step-by-step operation. 1. Thermostat control calls for cooling. A space thermostat or building control detects temperature above set point and signals the chiller to start or to carry load, staging variable speed. 2. Pumps start and water circulates. The chilled water pump runs and pushes chilled water to air handling units, AHUs, fan calls, process loads, etc. Warm return water comes back to the chiller's evaporator. 3. Warm chilled water enters the evaporator. Return chilled water, warmer, flows through the evaporator's water side and transfers heat to the cold refrigerant on the refrigerant side. 4. Refrigerant evaporates, heat absorption. Low-pressure liquid refrigerant in the evaporator absorbs heat from the chilled water and boils into low-pressure vapor. As a result, the chilled water is cooled. Typical supply ~4, 7 degrees C, return ~8, 12 degrees C for many systems. 5. Cold water goes back to the building. The now cooled chilled water leaves the evaporator and is delivered to the building loads, repeating the chilled water loop. 6. Refrigerant vapor goes to the compressor. Low-pressure refrigerant vapor is drawn into the compressor. The compressor does work on the vapor, increasing its pressure and temperature to a high-pressure superheated vapor. 7. Hot high-pressure vapor flows to the condenser. The compressor discharges hot refrigerant vapor into the water-cooled condenser. 8. Heat is transferred to condenser water. Condenser water, cooled by the tower, flows through the condenser tubes and absorbs heat from the hot refrigerant, condensing it to a high-pressure liquid. The condenser water temperature rises and is pumped to the cooling tower. 9. Cooling tower rejects heat to the air. The warm condenser water goes to the cooling tower where evaporative cooling removes heat to the atmosphere. Cooled water returns to the condenser. Typical entering condenser water might be ~26, 35 degrees C depending on climate design. 10. Liquid refrigerant is metered by the expansion device. High-pressure liquid refrigerant passes through the expansion valve, TXV or EV, where pressure and temperature drop, producing a cold-to-phase mixture that enters the evaporator. 11. Cycle repeats. The cold refrigerant absorbs heat in the evaporator again, and the vapor returns to the compressor. Continuous loop while cooling is needed. 12. Controls and protections operate automatically. Safeties, low-high pressure cutouts, flow switches, freeze protection, all management, anti-short cycle timers, VFD control for capacity, keep the chiller safe and efficient.